This is the first video that goes along with this figures PowerPoint slides that you have in Module 9. So this video is going to talk about the figures, frequency distributions that are for one variable, and then we're going to talk about some charts that are for more than one variable. So first, the charts, the figures that show one variable. So this is a bar chart. A bar chart is for categorical data. And so these are strictly categories. This happens to be people's preferences for ice cream flavors. So each chart represents how many people, each bar represents how many people prefer each of these flavors. As you can see, Rocky Road is the biggest hit here, and with 6 people, these are 24 people altogether, I think, in this, and Peach and Black Cherry, only one person each, one person each. So this is a bar chart. Notice there are spaces between the bars, and it's just one variable. That is the preferences for ice cream flavors, and on the horizontal axis we have each of the flavors, and on the vertical axis we have the number of people preferring those flavors. All right. So then a histogram is very much like a bar chart. It's a plot that shows the frequencies of a continuous set of data, not just not a categorical data, but a continuous set of data. So now when you have a continuous set of data, in order to display them, you have to split them up in what are called bins or ranges. So each bin contains the number of scores that are within each range. So you might go from 1 to 5, 6 to 10, 7 to 11 to 15, and so forth. Unlike bar charts on histograms, there are no spaces between the lines on the chart, indicating that it's a continuous variable, although you might have some missing bins, and so we'll see one like that next. Okay, so this is a histogram that displays the number of people in each age group in a sample. And so down here we have a definition of the bins, 20 to 30, and then they've already put the data in here. There's somebody that's 25 years old, somebody that's 22 years old. So both of those go in this first bin, so you see that up here. And then 30 to 40, we have everybody here. It's between 30 and 40. There's 4 of those in that bin. 30 to 40 goes here, and so forth. As you can see, there's nobody from 80 to 90, so that bin is left out here, or indicating 0 people in that bin. But otherwise, these bars are clinging together, adhering. So again, this is a frequency distribution. It shows one variable, age, and the number of people in each variable, in each bin. But this is again a histogram for continuous data. So here's another histogram that might look familiar to you. This is, of course, a picture of the normal distribution. And as we've talked about, the normal distribution, this particular picture has 0 as the mean of this distribution, and that's how they usually show it, and then a half a standard deviation below the mean as minus 0.5, a half a standard deviation above the mean plus 0.5. So as we've talked about this earlier, as you've seen probably earlier, that within a half a standard deviation around the mean, you have about 38% of the of the values, and between 1 standard deviation of the mean, you have 38 plus 15 plus 15, which adds up to 68% of the values. So 68% of the values of a variable that is normally distributed are expected to be between -1 standard deviation and +1 standard deviation of the mean. Now I've put out here a indication of where 1.96 standard deviations is. 1.96 standard deviations happens to be the point at which that in between -1.96 and +1.96 standard deviations in a normal distribution, 95% of the cases will fall between these two areas, 1.96 minus to 1.96 plus. So very near 2 standard deviations, you get almost all of the subjects, but not quite, 1.96. And you'll see that 1.96 again. If you don't recognize it, we'll talk about it again. Now, many things can be arrayed on a frequency distribution, and one of the things that can be arrayed on it is what's called a sampling distribution. So a sampling distribution is something that statisticians use to figure out the probabilities of things, and a sampling distribution is based not on standard deviations as the other one was, but like this one, but on standard errors. So we talked about the standard errors when we talked about the confidence intervals in the statistics lecture on the last in the last module. But a standard error is calculated by taking a standard deviation and dividing it by the square root of n. So anyway, but this is a sampling distribution. A sampling distribution is something that's never calculated. It's assumed for various statistics. And again, between minus 1.96 and plus 1.96 standard errors, that is considered the 95% of the values for a particular statistic are between those two, and those are the kind that this is the kind of thing that figures in confidence intervals. We talked about confidence intervals the last time. So that's the standard. So this is a sampling distribution. Again, I'm just showing it to you to indicate that a sampling distribution is made up of standard errors. Okay, we'll stop there.